This video examines the degree of interaction between the scrubber duct inlet temperature loop and the remaining loops in the single loop configuration. The configuration of the scrubber duct inlet temperature loop is based on the assumption that opening the hot air damper to scrubber duct inlet will increase the scrubber duct inlet temperature. The previous video concluded that this is not consistent with the long-term process behavior. With the other three loops on manual, opening the hot air damper has somewhere between no effect and a small decrease. With the other three loops in auto, opening the hot air damper to scrubber duct inlet increases the scrubber duct inlet temperature. However, this is due to the control action taken by the other loops. The behavior with other loops in auto is very, very different from the behavior with these loops in manual. This suggests a high degree of interaction. To proceed from a qualitative analysis to a quantitative analysis, we have two options. One is to conduct tests directly on the process. The other is to simulate the process and then conduct the same tests on the simulation. The off-gas process is relatively fast, but even so, process testing is not a trivial endeavor. The alternative of simulating the process is usually more attractive. The testing procedure is basically the same, whether on a simulation or on the actual process. Our focus is on the scrubber duct inlet temperature controller. The measured variable is the scrubber duct inlet temperature. The controller output is the opening of the hot air damper to scrubber duct inlet. The test will obtain the response of the measured variable to an increase of 5% in the controller output. Initially, the process is lined out at its normal operating conditions. All controllers are on manual. To start the test, we increase the output of the scrubber duct inlet temperature controller by 5%. We must wait for the process to line out. Then we place the simulator on hold. Opening the hot air damper increases the hot air flow to scrubber duct inlet. Initially, this increases the scrubber duct inlet temperature, the cyan pin, but this is a transient effect. Opening the hot air damper decreases the hot air pressure, the green pin. This increases the pressure drop across the fresh air damper, which increases the fresh air flow. This decreases the hot air temperature, the red pin. The baghouse inlet temperature, the yellow pin, also decreases. There are two factors. Some hot air is redirected from baghouse inlet to scrubber duct inlet. In addition, the hot air temperature decreases. The long-term decrease in the scrubber duct inlet temperature reflects the extent to which the fresh air flow increases. Redirecting hot air from baghouse inlet to scrubber duct inlet has at most a nominal effect on the scrubber duct inlet temperature. Place the simulator and run. Then restore the output of the scrubber duct inlet temperature controller to its original value. How can one assess the degree to which interaction is affecting the scrubber duct inlet temperature loop? One approach is to compare two responses to the same change in the controller output. One response is obtained with all loops on manual. We just did that. The second response is obtained with all loops on auto. The simulated process is lined out at the normal operating conditions. First, switch the hot air pressure controller to automatic. Then switch the hot air temperature controller to auto. Then switch the baghouse inlet temperature controller to auto. The scrubber duct inlet temperature controller remains on manual. Finally, we increase the controller output by 5%. If no interaction is present, the response with the controllers on auto would be the same as the response with the controllers on manual. The degree to which these responses differ reflects the degree of interaction. In this case, they are very, very different, suggesting a high degree of interaction. Place the simulator on hold. Scroll the trend display to the response with all loops on manual. Note the scrubber duct inlet temperature response, the cyan pin. Then scroll to the current time. Note the scrubber duct inlet temperature. The large difference between these two responses is obvious. Measures such as the relative gain can be applied to quantify the degree of steady-state interaction. But given the difference between the two responses, simply assessing that it is very large is sufficient for our purposes. We need to revise the control configuration to reflect our understanding of the behavior of the off-gas process. This is the subject of the next video.